Well, I don't have the experiment to show you. What I did, I went into microcap and I wanted to test out another instance, another situation involving parallel capacitance inside of an inductor. And what I did was I put it inside of the lead inductance of a spark gap, the spark gap macro of a neon bulb that microcap has. It's basically an equivalent circuit to the behavior of a neon bulb spark gap, involving capacitors and inductors and resistors and current sources and zero voltage sources and various items of interest that creates the behavioral characteristic of a neon bulb spark gap. Because although it seems simple, what a spark gap is, you know, a gap inside of a glass enclosure with neon inside, and but it really behaves in a very bizarre fashion, a very complicated fashion, and so it requires an equivalency in the form of a circuit to emulate its behavioral characteristics. Well, I went into that spark gap macro and I placed parallel capacitance inside of its lead inductance, and nothing happened when I put it in a circuit involving only two other elements, an inductor and a capacitor. And the capacitor was precharged with a microvolt. And then I took the spark gap out and I put the parallel capacitance inside of the inductance and raised the inductance. So it wasn't just 1 Henry anymore, now it was 10,000 Henries, and nothing happened. And what it leads me to surmise is that yesterday's experiment, in which I took Byron Brubaker's version of Tesla's hairpin circuit, which involves mutual inductance because he has a transformer in there, to take the signal and transfer it over to 3 capacitors, 2 in series, 1 in parallel, and then it goes into a full bridge rectifying arrangement of 4 diodes to translate that AC into DC. And then he feeds the DC to let's see if I can say this right, a Crocroft voltage multiplier. It's a voltage multiplier. Now, I didn't do that. I didn't use a voltage multiplier because I realized I could do this without a voltage multiplier if I play my cards right. And I did, by putting 1e to the 20 of parallel capacitance inside of the various inductors that are busy doing the transferring. And so what today's experiment failure and yesterday's success leads me to surmise is that parallel capacitance inside of an inductor has nothing to do with affecting some kind of behavioral modification of that inductor in terms of its self-inductance. But when that inductor is involved in a situation of mutual inductance between itself and another inductor, then, and when the Henry, I think the Henrys have to come up a bit. Yeah, I was finding that out too. If I had severe reduction of inductance, self-inductance, the parallel capacitance would not effectively give me over unity in the situation of mutual inductance unless I brought up the Henrys. I don't know what the minimum is. I had it, well, I started seeing results when I had 1 millihenry. Okay, so but then it would quickly die out. But when the Henrys was, what was it? 1? No, I had it more than that. 10,000. No, 8. Yeah, I had 10,000 and I had 8. 8 seemed to be good because it sustained the over unity, and there were triangle waves of all things for quite a lengthy period of time. And what happened was 123 seconds I had it at. What happens was if I tried to take it longer than 123 seconds, the simulator maxed out and gave me an error message, matrix is singular, which was indicating to me that another level of incremental explosion of energy was taking place. So this is what I see sometimes happen, is that the circuit will go it's like a step. What do you call those? Yeah, a step. In a plateau, you know, you rise suddenly to one plateau and you hang there for a little bit, and then you suddenly rise to the next plateau above that one, and that one went beyond the ability for the simulator to simulate. So this is an escalating situation that is incremental. It does sudden plateau rises and hangs there, and then another sudden plateau. And so the sudden plateau that initially rose, it struggled with it for a few seconds, and then it would plateau at 1e to the 60, somewhere, give or take, give or take a power of 10. And that was on the transfer coils that were at 10,000 henries. But when I went to the load coil that involved two very disparaging or two very disparate values, because it was meant to represent the squirrel cage rotor in the center of a motor and the armature or the main coil on the armature of the stator coil of a single-phase induction motor. So I put 8 henries on the stator and initially 100 nanohenries on the rotor. And the funny thing was I wasn't even looking at the transfer coil of 10,000 henries each, 1 to 1. No, it was 1 to 3 actually. It was, oh, was it 10 or 10,000? Now I can't remember. Well, I made it 1 to 3. And so it was 3, on the 3 side, it was facing the diode bridge. See, I took out Byron Brubaker's, what's it called? The AC input, and I put in a capacitor with pre-charged with 1 microvolt in place of it, so that it would oscillate just like an AC input. But if you don't do something with that initial pre-charged input, it's going to die out and you'll be left with nothing. So the whole point is to challenge myself to take that little spark, that ember, and turn it into a bonfire, and I managed to succeed. Anywho, so the motor, when I brought the rotor coil up to 1 millihenry, at 100 nanohenries, it just zeroed out. It was 0 volts and 0 amps. While the stator coil at 8 henries took a few seconds and rose quickly up to around 1e to the 59 or 61, somewhere around in there. And then sustained that until the whole thing exploded at some duration point later than 123 seconds. And then the simulator couldn't handle it anymore. But when I raised the rotor coil, the squirrel cage rotor coil up to 1 millihenry, then I got this initial, I think it was Terra, and it was triangle waves. And all of the amps and the volts were in sync with each other, which tells me that these coils were consuming power while the production was happening somewhere else. And so I was only looking at the motor coils, so maybe it was happening at the diodes, maybe it was happening at the transfer coils, maybe it was happening at any one of the 4 capacitors. I don't know. I put the ground by the diode bridge. So I put it as far away from the load as possible. So the transfer coil was in the middle, the the motor load was on the left-hand side, and the diode bridge was on the right-hand side with the ground. Anyway, you go to Quora, and I posted it there under electrical science space. This is, what is this, August August something, 8th or 9th. I posted it, I guess, on the 7th or 8th of August 2021, and so it's there. And I also did a video the night before explaining Paul Falstead's version of what I'd done. So I'm trying to look for an equivalency between parallel capacitance within, now I understand, mutual inductance, within the self-inductances that are involved in mutual inductance, and DC transfer of an ideal transformer. And I think what happens is it's equivalent, but it's not exactly the same. So it's almost as if the parallel capacitance of the mutual inductance is storing the energy until it decides not to keep accumulating it anymore, and then transfers it over. And while it's storing it, it's replicating it. So it's using the same principle of negative current relative to voltage. such that the prior waves do not die out, and the new occurrences of waves simply pile on top of the prior ones, causing an accumulation of energy, accumulation of reactive power. And then when it finally exits the capacitor, it exits because for some reason it reached a critical mass point in which the amps and the volts were put back into synchronicity of positive unity power factor, taken out of their negative unity power factor condition of simply lossless accumulation. And so now then they just exit like mad dash, and that's why it was exhibiting watts, not reactive power, because over time it should diminish. Because the volts and the amps were in sync. Had they been out of sync by half a phase of oscillating cycle, it would have shown me that it was generating, the motor coil was generating power, not consuming it, but it was consuming it, so it's being produced somewhere else, and it's being consumed at the motor load. I didn't do a thorough analysis. I wasn't really interested. I just wanted to see if I got it over unity or not. So at this point, now that I understand the mechanics, you have to thoroughly analyze every single component to find out which one is producing power, which reactive component, either a capacitor or a coil, is producing power and which is consuming. And of course, resistors consume and diodes consume. But capacitors and coils are different. When you get them interacting, especially you got multiples of them, 2 or more capacitors and 2 or more inductors, silly things can happen. And that's what I found with Eric Dollar's analog computer in LMD mode. But that was very explosive with just spikes. Here, it quickly rises up to a plateau and then dissipates its power as triangle waves. So it's a very interesting behavioral alteration to how to go about creating over unity. There are all these variations of over unity. It's unbelievable the type of waveforms you can get and the behaviors of those waves. And that's what fascinates me, is the unique signature, the wave form signature to all of these different variations of over unity. So I just thought I'd share a little with you.